back to Linux administration and security. In this module, you'll learn how to work with logs and how to secure them. System logs are an important part of every IT administrator's life. They can tell you how well your system is performing, how to troubleshoot problems, and what the users, both authorized and unauthorized, are doing on the system. In this module, we will take a brief tour of the Linux logging systems and then explore a convenient method to help make your log reviews easier. Lastly, you will learn how to set up a remote logging server, complete with TLS encrypted connections to the clients. You'll find the Linux log files in the var log directory. The structure of Linux log files is pretty much the same across all Linux distros, but in the Linux tradition of trying to keep us all confused, the main log files have different names on different distros. On Red Hat type systems, the main log file is the messages file, and the log for authentication-related events is the secure file. On Debian type systems, the main log file is the syslog file, and the authentication log is in the auth.log file. Other log files you'll see deal with kernel messages. In Debian type systems, these are located in var log kern.log. This includes messages about what's going on with the Linux firewall. Red Hat systems send their kernel messages to the messages file. Then there are the usage logs. Var log wtemp records information about users who are logged into the system, and var log btmp holds information about failed login attempts. Var log last log holds information about the last time that users logged into the system. It really doesn't matter whether you're talking about the syslog and auth.log files on Ubuntu or the messages and secure files on CentOS. On either system, the files are the same, just with different names. The system log files and the authentication log files have the same basic structure and are all plain text files. This makes it easy to search for specific information with tools that are already built into Linux. It doesn't really matter which virtual machine we use for this, other than to keep the names of the files straight. I'll use my CentOS machine here. As you can see, I had to use sudo to access var log messages, which means that they are usually accessible only to users with root permissions. Let's look at a line from the file. March 28, 1:31:12. That's the timestamp on which the message was generated. Localhost is the host name of the machine that generated the message, and systemd is the service that generated the message. Here, the system daemon. Started fingerprint authentication daemon. That's what the service did. When it comes to searching for strings inside files, the grep command is the Swiss Army knife of Linux. Essentially, grep searches for whatever string you pass to it inside a file. Since all system log files are accessible to root privileged users only, you will have to use sudo to run grep on a system log file such as syslog on Ubuntu or messages on CentOS. What you're seeing here is the regular grep command. Like everything else in Linux, it is case sensitive. You can make your search ignore case by using the -i option. This will find all uppercase and lowercase instances of the string fail in the messages file. Or you can use the -w option to search for fail as a partial string inside other text strings. Lastly, the most comprehensive way to search would be to use sudo grep -iw fail messages. This will catch any occurrence of the string fail in the messages file, no matter whether uppercase, lowercase, or as part of another string. In general, if you don't know exactly what you're looking for, start off with a more generic search that will probably show you too much, like this one. Then narrow things down until you find what you want. Here you can see my sudo grep-iw fail messages command in action. Go ahead and pause this video to look at my output. How many times do you see the word fail? We've seen how file log messages can be accessed with a regular grep filter. Unfortunately, grep does not help us at all with the user monitoring files. This is where commands like who, w, last, and last log come in. Who shows you who is currently logged in, but w is much better because it shows you not only who is logged in, but also what they're doing. Here, who shows me with 3 different logins. The TTY7 line is my local terminal session, and the PTS1 and PTS2 lines are my 2 remote SSH sessions from the 192.168.0.251 machine. Gandalf and Frodo are remotely logged in from 2 other machines. Now, the W output shows 5 users, but they're really only 3 since it counts each of my login sessions as a separate user. :0 under the from column for my first login means that this login is at the machine's local console. The bin.sh part shows that I have a terminal window open, and the etc, xdg, and so on stuff means that the machine is in graphical mode with the xfce desktop. The PTS1 line shows that I've run the W command in that window, and the PTS2 line shows that I'm not really doing anything in that window other than just having the bash shell open. Next, we see that Gandalf is editing a file. So I think that he's all good, but look at Frodo. PRIV in his line indicates that he is doing some sort of privileged action. In other words, Frodo has most likely pseudo privileges and can act like root in our system. We'll have to dig deeper and review our authentication logs to see why Frodo is allowed such elevated privileges. 2 more commands can help us understand more about user activities on our system: last and last log. In normal usage, the last command pulls information from the var log wtmp file. Without any option switches, last shows when each user has logged in or out and when the machine has been booted. Using the -f switch shows you all failed logins. Finally, there's the last log command, which pulls information from, you guessed it, the var log last log file. This shows a record of all users on the machine, even system users, and when they logged in last. But that's not all. Check out what our textbook has to say about rsyslog and how to set up the rsyslog logging rules, and about the journal delogging system and the journal CTL utility. The logwatch utility will help you easily solve all your logging headaches. And now let's watch Ed Goat set up a centralized syslog server.
In this video, we're going to set up a centralized syslog server running off of Fedora 30. Now, I've done this before in a couple of different other distributions. Fedora has its own intricacies, so we'll see how that changes our plan. Now, the first question you may be thinking of is, what is a syslog server and why do I want a centralized syslog server? Well, every single device on your network, a Linux device, a switch, even an IP camera, they all generate log files of some kind. And you probably want to look at those log files occasionally. Now, the problem is that if I want to look at the log files for this firewall, I have to go to the firewall in order to get those log files. Some devices don't hold those logs very long, so if it's been more than a couple of hours or a couple of days, those logs may no longer be there. Additionally, there may be situations where something happens on the firewall and the switch and the router, and I need to know which happened first. What was the sequence of events between the router and the firewall? Was there an attack from outside in or from inside out? So most of these devices, you can actually forward their log messages using a protocol called syslog to a centralized syslog server. So if I send all of these logs to my one syslog server, the next time I need to look at error messages from my Linux host, well, I just look on my syslog server and I can see all of the logs pertaining to that system. And then I can also see all the events for this Linux machine as it ties into the Windows machine and our IP cameras and all the other network devices in our environment. Because everything's in one place, I can easily search for it and correlate the events between them. So what steps do we need in order to do this? Well, we have 6 steps right here. First off, we need to configure our logging location. So I've got my Linux host right here, and we'll go ahead and do that. I want to go ahead and store all of my logs in the /var/log/syslog directory. Now that directory doesn't exist already, so I need to, as root, go ahead and make that directory, sudo mkdir for dir, make dir, and I want var log syslog. Prove I am Justin so that I can go ahead and run it. So I now have the location where I want my logs to go. I want them to be stored in this var log syslog directory. I'm not too concerned about permissions at this point because, well, the root user is going to be the one running our syslog, and the root user is going to be the one reading the logs almost always. Therefore, I don't necessarily have to change the permissions beyond that. Next step is I want to open up the firewall. Because all of these messages are coming across the network, I need to allow the network to accept them. So, in order to do that, what we do is we use the command called firewall-cmd. What zone do we want to change? Well, we want to change the public zone. And what do we want on the public zone? We want to add a port. And that port is going to be 514/UDP. And we want this change to be permanent. Now syslog can operate off of both UDP and TCP. So I'm actually going to just up arrow, go back to that line there. Change UDP to TCP, and now I'm just going to run firewall cmd with reload. To make those changes take effect immediately. All right, we are step 2 down. That was open the firewall, configure the log location. Those 2 are down. The next step is to install our syslog. Again, an easy step. In order to install our syslog, we use the dnf install command with our syslog. This will take a minute. It's going to evaluate its database, see if it's up to date, and then go on up to Fedora servers, download the latest version of our syslog, and install it for me. And while that's finishing, step number 4 is to configure our syslog, and this is really where all the magic comes. So in order to configure our syslog, the configuration file we need to edit. So sudo vi, because it's a configuration file, you always need to be running as root. And we want to edit the etc rsyslog.conf file. There are 2 edits we want to do in here. First off is we want to enable a couple of modules. The modules we want to enable are these 2 right here. One for UDP reception and one for TCP reception. So what we do is we just edit the last 2 lines out of each of those. So we remove the comment from in front of the module and the input, and from the module and the input. So this means it will now accept messages via UDP on port 514 and messages via TCP on ports 514. The next thing we need to do is we want to organize all of the messages that are coming in. All of these messages by default will end up in one giant file, which, hey, if we only have 2 or 3 devices, it may be perfectly fine, but if we have 200 or 300, then we might want to separate them out into their own separate files. I'm just going to scroll on down to the very bottom here. And I'm going to go ahead and add in my own rule. What I want to do is I want to create a template. This template I'm going to call per host log. And I'm going to say that I want it to store files in /var/log/syslog. And then I want it to name that file off the host name that comes from the syslog message. So what this will do is it will create a file in varlog syslog, and then it will store any logs based off of the host name of the log itself, or from the logging message. So once that template is created, now we have to put some logic in here to tell it to actually start using this template. And so I'm going to create some commands here from host-ip starts with 192. So what this is doing is this is evaluating the from IP for the host, and it says, hey, if you start with 192 dot. So my network is 192. If mine was 10, it would be 10 dot. Otherwise, whatever my local network would be. Then add some funky command here that says to run the per host log. So if this IP starts with this, then go ahead and use this template. And then lastly, because now we've gone ahead and used this template, we want to tell it to go ahead and stop processing any other activities. This is actually the last line in the log file here, in the configuration file here, so it's not explicitly necessary. However, it's good practice anyways. So let's go ahead and save that, and then restart the systemctl, restart the rsyslog process. And really quick, I want to just view the status. And that's great. There's no red here in the screen. That means it loaded up the configuration. I've had it pop up a couple of times with some error messages there. Oftentimes it was a simple typo. Specifically, the H for host wasn't capitalized on one line, but was on the other. All right. So we've configured the log location. We've opened the firewall for remote systems to access us, to send messages to us. We've installed syslog. We've configured syslog to receive messages across the network, as well as put them in their own separate file every time. Now what we want to do is we want to test it. If this was a production network, I could simply go out to my routers and switches and configure them to send messages to me. This is a virtual environment that is composed of one virtual machine. Therefore, I can't necessarily do that. I instead have a script here which will help us simulate this. I'm going to go ahead and copy this and download it onto this local machine. I'm going to use the command wget in order to download it. Copy and paste doesn't work. Sometimes copy and paste just does not work. In that case, I can just type it. raw.git hub user content.com/code/syslog-generator/master/sysslog-gen1.sh. And if I did that without any typos, GitHub user content.cm. I did not do it without any typos. There we go. So I now have the script file. I need to edit it. I need to modify one little thing in here. Basically what I want to modify is my destination here. And I'm not entirely sure what my IP address is. So I can open up a new window here. ifconfig tells me my IP address is 192.168.0.121, and so that's what I want to change my destination to. And while I'm here, I actually want to uncomment another line that simply shows me what's going on. And cross our fingers, that should be everything we need to do. Let's mark this as executable and go ahead and run it. So this is echoing out exactly what it's doing. It's going ahead and running netcat. It's sending to my IP address on port 514 UDP various syslog-esque messages. They're very basic messages, but they're messages nonetheless. In this other window, we should now be able to, as sudo, we should be able to view or do an ls of the /var/log/syslog folder. And there we see our log files are being generated. In fact, if I do an ls-l, then we can start seeing that the sizes increment over time. So there we saw, let's see, 192.168.190.2 went from 338 bytes to 470. So basically what's happening is all these messages are coming in. They're simulated. They're really, really boring messages, but they're coming in theoretically from different hosts, different sources. Our syslog server is receiving them and is now organizing them into their own files. And so I can actually tail one of these guys with the /follow switch. And we'll see as the messages are coming in from .2 there, our logs will increment. And by this way, we can actually watch just those error messages for those devices we want. Or we can look at all the error messages across all of the devices based on our timestamps or any other method that we might. So it was a success. That's great. The one final step that's remaining is to set up log rotate. So by default, these log files will grow and grow and grow and grow. And a couple of weeks or a couple of months or even a couple of years from now, our system will crash because the hard drives are full. In order to fix that, there's a program called log rotate, and you just tell it, hey, look in this directory, rotate these log files around and on a daily basis, and then delete the old ones. So that's what we want to do. Gonna go ahead and cancel my sample script here. And the log rotate files are in /var/log rotate.d. And you can see all these services here that all have different log rotate sessions. There is one for our syslog, so I'm going to actually copy that. Let's see, log rotate.d. I'm going to, as root, copy the R syslog and just call it syslog. The file name in and of itself is not important here. Now I'm going to go ahead and edit that syslog file and we'll see how it works. So what happens is up here is a list of all of the files that we want it to look at. And then down here is all of the settings we want it to do. So we don't want our new file to look at these logs right here because we already have something that looks at those logs. I'm going to go ahead and delete those. And then I'm going to add in that I want it to look in var log syslog and then star.log. That way it'll look at all the log files that are in my system. Most of these commands are pretty much what I want. There are lots and lots of options. You can look at the log rotate settings. What I want in here specifically is I want to add in a rotate 365. And what this means is it will go ahead and it will rotate all of my log files for 365 iterations. And I want it to do that daily. So now every single day it will go through and it will rotate my log files. So this 192.168.190.2.log will at midnight or 2 a.m.-ish, whenever the log rotate command runs, it will rename that to a .1 at the end and then create a new log file for me. And it will do that for 365 days, and then it will compress them as necessary. After 365 days, it will go ahead and delete those. And in fact, we can even add that in as another option, max age 366. So it will go ahead and delete all of those files for me and make sure that everything is nice and tidy. 1 year of log files actually turns out to be quite small. So you're actually not having to worry too much about the environment, about your system's environment. So I'm going to go ahead and save this. And that should be everything. We have gone ahead and configured our log location. Best practice would actually be to put this on a separate drive. So feel free to add a new hard disk to your system and mount it to that same location, var log syslog. We then opened up our firewall to allow all of our remote devices to send us syslog messages. We installed our syslog system. There's lots of different syslog programs out there. Our syslog currently appears to be one of the best. We configured our syslog to not only listen to the network and accept messages from it, but also to put every single network-based message into its own folder. We tested it. It was a quick and dirty script, but we tested it and we saw that it did in fact work. And then we set up log rotate in order to maintain the system in the long run.
And again, there's even more to the centralized log server. Grab your textbook and be sure to read up on how to configure your remote log server with an encrypted connection. This brings us to the end of our introduction for this module. Once you have worked through all of the materials, you will have learned how the Linux log files are arranged and how they work. You will also be able to work with rsyslog and journald and use logwatch in order to improve on all the manual work. Lastly, you will set up your own remote log server. Thanks for watching, and I look forward to seeing you in a future video.